I hope you people can recognize this differential equation. It is non-homogeneous linear differential equation with constant coefficients a1 and a2. And we know its general solution is given by y equal to complementary function plus particular integral. We know how to find the auxiliary equation and finding the roots. Looking at the nature, we are supposed to write the complementary function. And for the particular integral, we have learned three cases. If my f of x is exponential function, cos or sine, or if it is a polynomial. For exponential case, we know that we are supposed to replace capital D by a to find the particular integral, provided the denominator is not 0. If it is equal to 0, we should multiply by independent variable, then differentiate the denominator once, then go for the replacement of D by a. And for cos and sine, method says replace d square by minus a square. And even in this case, if the denominator becomes 0, we know how to handle, multiply by the independent variable, differentiate denominator once, and replace d square by minus a square. That should be done. Instead, if it is a polynomial, we know we are supposed to employ division method. That's quite simple again. Now the question is, if my f of x is anything other than these three, like tan, cot, secant, cosecant, log, or e power x, or something like this, how do we handle them? That is what our next question is. For that, the answer is method of variation of parameters. Yeah, this is a general method which we can employ to solve any differential equation with constant coefficients and see how does it works. First of all, we are supposed to find the complementary function for the given differential equation, and definitely it will be in the form of c1 ux plus c2 v of x. Since it's a second order equation, we are expecting only two arbitrary constants c1 and c2, and the function which is multiplied to c1 is called u, and the function which is multiplied to c2 is called v. Once if we know this, we can find the value of this Wronskian, this determinant u, v, du, dv. And if it is not equal to 0, we claim solution of the given differential equation exists. If it is equal to 0, we claim solution does not exist. Once if it is not equal to 0, we can note that we can find the solution of this differential equation in the form y equal to au plus bv. Observe this carefully. This looks exactly similar to your complementary function, where in the place of c1 I have written a and in the place of c2 I have written b. That is, I have just changed the constants into the variables, and that is what called method of variation of parameters. Now, how do you find the value of a and b? It is found through these two formulas. A of x equal to minus integration of v f of x by w dx plus k1. B of x equal to integration of u f of x by w dx plus k2. F of x by w is quite common in both, and f of x is this RHS, w is the Wronskian, and v and u are taken from the complementary function. But should note two things. The first point is negative sign is only with the a, it is not with b. Second point is to find the value of a, we are using v, and to find the value of b, we are using u. Observe it again. To find a, I am using v. To find b, we are using u. Once if a and b are found, you can note our general solution is again y equal to au plus bv. This is not just we have written, so this has a clear proof to prove this result. Now let me try to understand this working rule through an example. This is what the given differential equation is. It's a second order equation, and obviously we are expecting two roots for our auxiliary equation, and the two roots here in this case are 3 and 3. Roots are real and equal, so our complementary function is c1 plus c2x e power 3x. Then we should put it in the form of c1u plus c2v, that is c1 e power 3x plus c2x e power 3x. Now the function which is multiplied to c1, that is our u, and the function which is multiplied to c2 is our v. Once if these two are known, we can write the Wronskian. But we need to know what is du and dv. Du is differentiation of u, that is differentiation of e power 3x, and dv is differentiation of x e power 3x, product of two functions. Product rule should be used. So x into differentiation of e power 3x plus e power 3x into differentiation of x. Once if it is done, so we are supposed to evaluate the determinant. So this term into this minus this function into this function. So that is given by 3x e power 6x plus e power 3x into e power 3x, that is e power 6x, minus 3x e power 3x into e power 3x, that is e power 6x. On simplification, it is just e power 6x, and it is not equal to 0. You can find your solution, that is given by y equal to au plus bv. So a is given by the formula. If you know this, substitute v of x in it, f of x, and divide by w dx plus k1. So go for the simplification. That gives minus dx divided by just 1 by x plus k1. So integration of 1 by x is what? Minus log x plus k1. That's what our a is. B is given by integration of u f of x by w dx plus k2. U is this function, f of x is e power 3x by x square, and w is e power 6x. So if I substitute them, we will get 1 by x square, and integration of 1 by x square is minus 1 by x plus k2. Now substitute all these things back in your general solution. So your y equal to a should be written first, that is minus log x plus k1, that should be multiplied by u, which is e power 3x, plus b is nothing but minus 1 by x plus k2, and that should be multiplied by v, that is x e power 3x. So this is how any problem under method of variation of parameter works. And please have a look at this one. Here you can find k1 e power 3x, and one more term is k2 x e power 3x. So these two terms together gives our complementary function, k1 e power 3x plus k2 x e power 3x. We know that our general solution is basically made up of what? Complementary function plus particular integral. Here also you can see the same thing. This k1 e power 3x plus k2 x e power 3x gives the complementary function, and the remaining term gives particular integral for us. Let me see two more problems to understand this better. So y double dash plus 4y equal to 4 secant square 2x. First of all, put it in the standard form, write the auxiliary equation, and your complementary function in this case is c1 cos 2x plus c2 sin 2x. Obviously u is cos 2x, v is sin 2x, differentiate u, differentiate v, substitute them in our Wronskian, go for evaluation of this, cos 2x into 2 cos 2x, that is cos 2 cos square 2x, minus into minus plus 2 sin square 2x, that gives 2, as cos square theta plus sin square theta is 1. Wronskian is not 0, so we can go for assuming our general solution is y equal to au plus bv. Write the formula for a, substitute v, that is sin 2x, u is f of x is 4 secant square 2x, divide by w is 2 dx plus k1, and you can note 1 secant is written as 1 by cos into sin becomes tan, 1 secant is kept as it is. This is secant 2x into tan 2x. Integration of this is secant 2x by 2, because differentiation of secant 2x is what? Secant 2x into tan 2x into 2. That is what we written here. So that is nothing but minus secant 2x plus k1. That is what my a value is. B is, we are doing the same thing, and here cos 2x into 4 secant square 2x is there. 1 by cos into cos cancels, and 1 secant remains here. So integration of secant is given by log of secant 2x plus tan 2x. So that is what I have written here, that is B. So next our general solution is as usual, y equal to a value is written into u plus b into v is written. So let me see one more example now. D square minus 3d plus 2y equal to cos of e power minus 6. You can note that even this problem cannot be solved by the known methods. We are supposed to employ the method of variation of parameters even for this. Find the roots 1 and 2. So complementary function is c1 e power x plus c2 e power 2x. U is e power x, v is e power 2x, du is e power x. dv is 2 e power 2x. Substitute everything in Wronskian, and solving that you have 2 e power 3x minus e power 3x, that is equal to just e power 3x. Wronskian is not equal to 0. Assume our general solution is in the form of y equal to au plus bv. A is given by minus integration of v is e power 2x, f of x is cos of e power minus x, divided by w is e power 3x dx plus k1. So on simplification, e power minus x, because e power 2x cancels, we get e power minus x cos of e power minus x dx plus k1. We can't solve it directly. We're supposed to make use of some substitution method. So that is what I'm doing here. I'm assuming that e power minus x is equal to t in this case. That says minus e power minus x dx equal to dt. So minus e power minus x into dx becomes dt. So it is just cos t dt plus k1. Integration of cos t is given by sin t plus k1, but t is nothing but what? E power minus x, so it is sin of e power minus x plus k1. Now find the value of b, that is given by integration of u. U means it is e power x, f of x is cos of e power minus x, by w is e power 3x dx plus k2. On simplification, e power x x cancels, we get e power minus 2x multiplied to cos of e power minus x dx plus k2. Even for this problem, the same problem as the previous one, so we should go for the substitution. That is what I'm doing. E power minus x equal to t is taken here. So e power minus x into t, e power minus x equal to t, so minus e power minus x dx equal to dt for us. So e power minus x dx becomes minus dt. So in this e power minus 2x, I got e power minus x into e power minus x. One e power minus x is taken with this dx to write dt. Okay, so that is what this dt is. And one e power minus x is left out, that is nothing but t cos t dt plus k2. Now we should integrate this by parts because it's a product of two functions. I will treat this u as my first function, cos t as my second function. So what the integration by parts says, first function is kept as it is into integration of the second function minus integration of the second function into differentiation of first function. That is what I have written, sin t into differentiation of t becomes 1 into dt plus k2. That is nothing but minus t sin t is kept as it is, minus into minus, that is plus, and integration of sin t is what? Minus cos t. So that is nothing but plus cos t in this case. So minus is kept outside only. So it is plus cos t. Now if you just take minus sign inside, you can note that. So it is minus t sin t, minus into minus plus, and one more minus sign, that makes it minus cos of e power minus x plus k2. That is, I have written everything back in terms of e power minus x. So our general solution is y equal to a into u plus b into v. So this is how any problem under method of relation of parameters works. I hope you people are comfortable with the method now. If you have any doubts, so please get back. So thank you.